how X-ray fluorescence is a powerful technique than other similar techniques, because we know that there are similar techniques like EDX, sometimes it is called EDS, and it is also used for elemental analysis. This technique is usually performed along with scanning electron microscopy analysis. And we know that these techniques are basically performed using electrons. And we know electrons do not have that penetration power. This is why these techniques are for surface, for very, very thin film. However, XRF is basically used for bulk sample, for bulk analysis. So this video is very, very important because I posted few questions on the YouTube community and you can see the responses here. In XRF analysis, which hit the sample? So most of the responses was both electron and X-ray. No, this is the wrong answer. The correct answer is X-ray, because X-ray has more penetration power. This photon is also not correct because photon can be LED, photon can be UVB, photons can be gamma rays. So X-ray is the correct answer. Similarly, I asked which technique is more suitable for bulk analysis. So the correct answer is basically XRF, and we can see that few responses correct this quiz here. You see, most of them says XRF and EDX both, because they do not differentiate between the XRF and EDX. This question is almost similar. Here the response was good, X-ray, because X-ray cannot ionize just like electrons. So X-ray has more penetration power. Similarly, I asked in XRF what happened when we increase the atomic number. So what happened to the XRF intensity? The answer was shoot up, increases. But most of the responses you can see, they said there is no relationship between these two, which is very strange. XRF basically works just like our eyes. Like our eyes make basically the image. So XRF work similarly. For example, we know that in vision, when you want to see some objects, we need four components like the source of light, like the visible light, and if you want to see any object, that is the sample, and there is a reflection to our eyes, and then our brain make the image. So these four things are very important. Similarly, in XRF, we have X-ray is a source to bombard the sample, and this is the sample to be analyzed. This sample may be gold, maybe compound, maybe jewelry elements, anything, cements, etc. Then we get the XRF, mean the fluorescence X-ray basically, and detector basically detect it, and then we process the data and we get information in the form of here X-ray energy here, X-ray energy here, and here we have intensity. And these two parameters are basically give us a lot of information about the qualitative and quantitative analysis. Now let's describe how this XRF produce. So we know that this is general atom. This is atom of gold or anything. So what basically happened when we strike X-ray on the samples? So the core electron emit from the atom. Now there is a vacancy now. So there is a probability that the electron from the higher shell will jump. So in this case, the electron from L shell may jump to fill this vacancy, and when this electron jumps, so there is an energy difference, and that difference is basically emit in the form of X-ray, in the form of photon, and that is basically called fluorescence here. And that line we call basically K alpha line. Similarly, there is a probability that the M shell electron will jump to this, we fill the vacancy, and that line we call K beta here. Now, there is also a probability that the vacancy can produce an L shell. When the vacancy produces an L shell, now the M and L shell will fill this vacancy, and we will get L alpha and L beta